SpaceX carried out the historic Demo 2 mission with NASA over the weekend, successfully becoming the first commercial company to launch humans to space on its own spacecraft. So what better way to celebrate than by following it up this week with another launch? The Falcon 9, carrying the satellites, will attempt a landing at sea, and the company will also try to recover both halves of the nose cone, or fairing, which is beginning to become a routine part of each mission. This would be the eighth launch of a batch of 60 Starlink broadband satellites, bringing the total in orbit to nearly 500. The company hopes to send hundreds more of its orbiting routers up by the end of the year, with an ultimate goal of tens of thousands in low Earth orbit to provide high-speed internet to almost anywhere on the planet. The project has been controversial among scientists and astronomers who worry about the brightness of the satellites, which have already interfered with telescopic observations of the cosmos. This mission, which is labeled Starlink 7, will carry SpaceX's latest attempt at a fix in the form of a sunshade called VisorSat that reduces the reflectivity of each satellite equipped with one. The company is expected to test at least one VisorSat in this batch and move towards all future satellites in the fleet being VisorSats. Since the first launch, 6 Starlink satellites have already failed. If a mere 5% of Starlink's satellites broke down during their estimated lifespan of 5 to 7 years, they would add many thousands of fragments of space debris to the 20,000 already under surveillance. Musk initially planned to put a quarter of his constellation at the altitude of 1,110 kilometers. 75% were due to be placed no higher than 600 kilometers below this altitude. Residual atmospheric drag will eventually cause a failed satellite to fall out of orbit. On April 17, SpaceX modified its plans and requested permission for all its satellites to orbit lower than 600 kilometers. This reduces the risk of broken-down satellites staying in high Earth orbit for centuries, but increases congestion in the low Earth orbit region. Beyond the operational risks, building, launching and maintaining such a gigantic network of satellites would require an enormous amount of raw materials and energy. Unlike the geostationary satellites commonly used by telecoms, Starlink satellites will stay in a low Earth orbit and cross the visible sky of a given location for just a few minutes. To follow and connect to them, buyers will have to use purpose-built phased array antennas. To make them affordable, they would have to be mass-produced, and SpaceX has asked permission for 1 million of them. For starters. More troublingly, competitors are sharpening their knives. Kuiper is backed by Amazon, OneWeb by billionaire Greg Weiler, and Hongjian is Chinese. Just as with electrical scooters, investors are rushing into massive production, and the results could be disastrous. Such unbridled competition has negative consequences from the environmental point of view as well as from the security and business ones. The theory is that whoever is first past the post will gain near monopoly power, cornering the potentially colossal market. We could well see several redundant satellite networks duke it out in the skies. Yet, there will be only one winner. Or none. On March 9, Elon Musk claimed that thanks to Starlink, anybody will be able to watch high-def movies, play video games and do all the things they want to do without noticing speed. Thus, Musk explicitly underlines his wish to reinforce already massively energy-guzzling digital activities, such as video streaming and online video games. What do you think? Starlink will create a better future? Comment your thoughts in the comment box below.